Hello friends, myself Mahajan presenting my new series of videos on Z Transform. Let us discuss that term Z Transform. Difference equations for discrete function can be solved by Z Transform, and it is analogous to the study of Laplace Transform. Z Transform has a useful mathematical tool to solve a difference equation involving pulse functions in control system of engineering. The first is the difference, basic difference between these two types of transform. If a continuous function is applied, we are getting a differential equation, and to solve that differential equation, the tool is Laplace transform. And instead of that, if we apply a discrete function, example impulse voltage, to an electric circuit, as a result we are getting a difference equation, and to solve that difference equation the tool available is Z transform. That is the basic difference between these two types of transform, and the study of that Z transform is analogous to the study of Laplace transform. If you are not subscribed my channel yet, please subscribe it, and for that you have to press the bell icon to receive the notification for my new videos. Z transform plays the same role in the analysis of discrete time signals as Laplace transform does it in the analysis of continuous time signal. This is the basic difference. For Laplace, the signal must be a continuous time signal, and for Z transform, it is a discrete type of time signals. Then we try to define the term of Z transform. Therefore, definition: Z transform of discrete time signal is defined as Z transform of that discrete time signal is given by or obtained by summation of n from minus infinity to plus infinity f of n, that function f of n, and multiplied by z raised to minus n. Here are two types of z. Capital Z stands for the operator of Z transform, and this small z stands for the complex number. Therefore, be very careful while applying this 2z, using 2z. Small z represent the complex number, and capital Z represent the operator of Z transform, and the result of that is f bar of z. We call this equation 1. This is the basic definition or the basic result to find Z transform of any discrete function f of n, where that small z is complex number. If the function f of n is defined for discrete values of n equal to 0, 1, 2, 3, and f of n is equal to 0 for negative values of n, then Z transform of f of n for this condition, f of n is equal to 0 for negative values, this formula is converted to a new one where we have to start summation from n equal to 0 to infinity, n equal to infinity, f of n multiplied by z raised to minus n, and whatever the value we are getting, it is f bar of z. Therefore, all the standard results we are obtaining by this definition, Z transform of f of n for this condition, f of n equal to 0 for n less than 0, its value is obtained by summation from n equal to 0 to infinity f of n into z raised to minus n, and whatever the value we have is denoted as f bar of z. And to evaluate this Z transform, we are using a sub result of binomial. Binomial theorem statement is known to all of you. X plus h and that bracket raised to n, its expansion is obtained as x raised to n plus n into x raised to n minus 1 into h plus n minus 1 by 2 factorial x raised to n minus 2 into h square, and so on. The last term is h raised to n. This is the binomial theorem, and a sub result of this 1 minus capital X raised to minus 1 means with x as 1 and h as capital X and n as minus 1. Using right hand side, we have the result. First one is 1, then plus x, then plus x square, then plus x cube, and so on. We go in reverse way. If we have sum of such type of term, 1 plus x square plus x cube plus so on, that is nothing but 1 minus x raised to minus 1, and this is 1 upon 1 minus capital X as 1 plus x square plus x cube plus x raised to 4, and so on. I mean, whenever we have such type of sum of the terms, that sum we can write as 1 upon 1 minus capital X with the condition mod of x less than 1. This is called as a region of convergence, ROC. Over this region only the series is a valid one or converges. Therefore, throughout this chapter I am using this result of binomial theorem. Then one simple problem, how we can obtain the Z transform of that given function. Let us try to solve one simple problem. If f of n is equal to a raised to n, condition n greater than or equal to 0, means for negative values the function is not existing, means its value is 0, then find Z transform of that f of n, and as it exists for positive values or equals to 0, then using that second form of definition, z of f of n is given by summation from n equal to 0 to infinity f of n into z raised to minus n, using that standard result or basic result. Then z transform of that function is here a raised to n, is summation from n equal to 0 to infinity f of n is a raised to n z raised to minus n. Therefore, it is summation of a z raised to minus 1 and that raised to n, and n changes from 0 to infinity. It is nothing but summation of transferring that z raised to minus 1 to a denominator. It becomes a by z whole raised to n changes from 0 to infinity. Then substituting n equal to 0, any number raised to 0 we get 1. Then n equal to 1 we get next term as a by z raised to 1. Next n equal to 2 we get a by z whole square. Next n equal to 3 we get a by z cube, and so on. We have infinite series in terms of a by z. This is somewhat similar to that previous example, previous result. 1 plus capital X plus x square plus x cube, and so on. That sum is nothing but, using that binomial theorem expansion, it is 1 upon 1 minus capital X, and that capital X is here a by z. And condition mod of a by z less than 1. Then it is equal, cross multiplying by z, we have z minus a divided by z, that we transfer to numerator. It becomes z upon z minus a, and transferring this to other side we get mod of z greater than mod of e. This is the region of convergence. This represents standard circle, center at origin, and radius is a. Therefore, if we try to show this, and this we call as f bar of z. Therefore, this is the required Z transform. By using this standard result to find Z transform. See the simple steps, 1, 2, 3. In 3 or 4 steps we are able to get the required Z transform. Important one is this, sum of this type of term is nothing but 1 upon 1 minus capital X, and that capital X is here a by z. If you remember this step, you can easily obtain a Z transform of any given function f of n, a discrete function f of n. And if you try to draw this figure, that figure is center at origin and radius e, and as that mod z is greater than that radius a, this represents the exterior part of that circle. This is origin, this much distance is a. Therefore, that region of convergence is the exterior part of this standard circle, mod z is equals to a. Over that region only, this result is a valid one, or that series is a convergent over this region of convergence. Or some more examples I will discuss in my next video. If you like my video, please share it, as well as subscribe to my channel, and to receive the notification for my new videos, you have to press the bell icon. Thank you. Thanks for watching.